Okay, we're going to be looking at the factor theorem today. And as usual, what I like to do is to relate what we do with polynomials to what we learned with elementary school math. So the first thing I want us to do is to look at these two questions. Is 5 a factor of 50? And what does it mean to be a factor? So you may want to pause the video here and think about that. So is 5 a factor of 50? Yes. And what does it mean to be a factor? Well, that means that I can take that number that I'm looking at, 5, and multiply it by something else in order to get the 50. Another way to look at it is to take 50 and divide it by 5 and get 10. What I want you to see here is that there's no remainder. Okay, so if you have a factor, the remainder equals 0. So now let's look at this question about polynomials. Is x plus 2 a factor of this given function? When I was looking at this problem right above here to see if 5 was a factor of 50, I said that when I divided, there was no remainder. Another way to say that is that the remainder equals 0. It's going to be the same thing down here with polynomials. My remainder needs to be 0. So how are we going to figure out if my remainder is 0? Well, up here with this 50, I did 50 divided by 5. And if you wanted to do that out with long division, you can. 5 goes into 5 one time, right? So we could do the same thing here. We can use long division or we can use synthetic division. So I could use synthetic division with -2 in my box, 1, -2, -13, and -10 with my coefficients. And you can see here that when I do the synthetic division, I have my remainder equals 0. So if f of -2 equals 0, then that implies that x plus 2 divides evenly. So x plus 2 is a factor. Another way to figure out if 0 is my remainder is to look at the remainder theorem. I can find f of -2 by plugging -2 in for x. So I'd have -2 cubed minus 2 times -2 squared minus 13 times -2 minus 10. And that's going to equal 0. Now, I could put this into the calculator just like it's shown here on the screen. Another way to figure out if this function value is 0 is to put this function in the calculator in the y equals and look at my table of values, and I see that when x is -2, y is 0. And a third way to use my calculator to help figure out if this value is 0 is to graph it and look to see if my function crosses the x-axis at -2. Is x minus 2 a factor of the given function? The first thing I want to do is take the opposite of this and put it in the box here. So I'm going to put +2 in that box. I'm going to write down my coefficients and use synthetic division to see if my remainder is 0. And it is. So if my remainder is 0, then f of 2 equals 0 implies that x minus 2 is a factor. Okay, I want to look at this idea about x minus 2 being a factor. I Okay, I'm starting off with this equation, 3x squared minus 20x plus 28. And I want to see, can I factor this and have one of these factors being x minus 2? Does that factor evenly? Well, what I found up here is that this is 3x minus 14. So this 3x minus 14 is a factor. Now let's suppose that we want to set this equation, or make this an equation, and we're going to set this equal to 0. Then let's look at each of these factors here set equal to 0 and solve. So I have x equals 2 or x equals 14/3 as my answers. So these two numbers, the 2 and the 14/3, are zeros of this function. That means that when I put 2 in place of x, I end up with a value of 0. If I put 14/3 in place of x, I end up with a value of 0. So these are my zeros of the function. When I graph, I'm going to have the graph crossing the x-axis at 2 and 14/3. Okay, now we're going to look at connecting a lot of these concepts. So let's consider the following function and its graph. So I have the function x cubed plus 2x squared minus 5x minus 6, and here's the factored form of that equation. All of the following statements are equivalent. They're pretty much saying the same thing. I'm going to be looking at this part right here, this x plus 3. Negative 3 is a 0 of the function. F of negative 3 equals 0. Negative 3 is the solution of f of x equals 0. Negative 3, 0 is an x-intercept of the graph, and I can see that right here. 0 is a remainder when f of x is divided by x minus negative 3, or x minus negative 3 is a factor of f. And I can say that the same is true for these other factors as well, the x minus 2 and the x plus 1. So lots of different ways to pretty much say the same thing.